welcome. Let's try to solve another Leetcode problem. 2134. Minimum swaps to group all ones together. So this is the second problem for this kind of minimum swaps. So we have an array nums. It's gonna have 0 and 1. So a swap is defined as taking two distinct positions in an array and swapping the values in them. So for example, this 0 and 1 can be swapped. So a circular array is defined as an array where we consider the first element and the last element to be adjacent. So this means this is 0 and the last 0 to be adjacent. So giving a binary circular array nums, return the minimum number of swaps required to group all ones present in the array together at any location. Yeah, so the meaning is that we are giving, so for example, I'm gonna use the first example. So it's gonna be 0, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 0. Yeah. So normally we have two arrays, and it is a circular array, and we want to calculate the minimum swaps. Basically, this is a kind of a pattern. So if it is a circular array, it means the head and the tail can be connected. So how can we connect them? We can just copy the same array. So this is the first array, and we copy it and we connect it. So if we connected it, we're gonna put them together. So the nums gonna be 2 times the nums. So this is gonna be the new nums. Now we are going to check what is the minimum swaps. We have two choices. So one choice is the fixed sliding window. Another choice is a non-fixed sliding window. So if the window is not fixed, so what's gonna happen? So if the window is not fixed, it's gonna make mistakes. So for the first example, this is okay, and because we are counting how many ones, so in total there are gonna be 3 ones. So for 3 ones, for here, what is the minimum swap? Because there's a 1, 0, so it is a 1. So this is okay, and the answer is 1. For the second example, if we connect them together, the answer is 2. It is okay. But let's just use another example. For example, this is a testing case, and another one we just copy it, and then we're gonna make them together, and then we're gonna count how many ones inside of the array. So before we making them together, so there'll be 1, 2, 3. There are gonna be 6 ones. Yeah, but how can we connect them? We're gonna connect them like this. So in this way, there will be 6 ones. But how many swaps? According to our, if the window is not fixed, so there are gonna be 2 zeros. Maybe you're gonna return a 2, but it is not like that. Maybe this one just, maybe this one just swap with this 0, and there's only 1 swap, and we can return an answer of 1 instead of 2. So this means, normally we cannot use a non-fixed sliding window. We have to use a fixed sliding window. First of all, we're gonna count how many ones. So in total, there are gonna be 6 ones, and then inside of the sliding, inside of the fixed sliding window, we're gonna count how many ones inside of the sliding window. But we need to fix the sliding window. If the window, if there are 6 ones, it means we're gonna fix the window size to be 6. If we fix the window size to be 6, the problem gonna be easier. So let's try to check. Yeah. So if we fix the window size to be 6 from here, let's fix it to be here, and this one to be here. So in this sliding window, there are gonna be 6 elements. As you can see, there are 6 elements, and how many zeros? There's only 1 0, so this means we just need 1 swap. So that's going to be the answer. So the problem is that we're going to connect the 2 nums together, and for 1 num, we're going to count how many ones. And this how many ones is the size of our window. If the window size, for example, this is 3, so for this fixed window, we're going to check how many zeros. And we're going to return the minimum zeros inside the fixed sliding window. Yeah. Now let's try to solve the problem. So first of all, we're gonna check the window size. So the window size is gonna be nums.count with 1. This is the window size, and then we're gonna connect the nums together. Yeah, because this is a circular array, and this is the basic pattern for solving such kind of a circular array problem. Yeah, and then we can use the pattern of sliding window. So L and result, left pointer gonna be starting from index 0, and result gonna be because we are going to calculate the minimum, so the result gonna be positive infinity. And then I'm gonna enumerate the nums. So for Rn in enumerate, so currently it's gonna be the 2 times nums. Yeah. So enumerate this nums. So I'm gonna prepare maybe a total. So this total gonna be called how many 1's. So if n equal to 1, so my total gonna plus equal to 1. Now I'm gonna check the window size. So if R minus L plus 1 equal to the window size I needed. Yeah, if it equal to the window size, basically I can get the answer. So the result gonna be the minimum with the result. So it's gonna be the window size minus how many 1's minus the total. Yeah, and then we're gonna shift to the left pointer. But before shift to that, we need to check the value. So if nums L equal to 1, so this total gonna be a minus 1. And finally, we're gonna update the left pointer. It's gonna plus 1, and this gonna be the final answer. We're gonna return the result. So if the result not equal to the infinity, it means we get a value. Otherwise, if it is equal to infinity, basically it means basically it means nothing. There's nothing inside. There's no one. There's no one inside. Basically, the window size is 0. Yeah, if the window size is 0, basically we cannot get anything. So we're gonna return 0. Yeah. Now let me run it to check if it works. Here should be else. Yeah. Yeah. Now let me run it. As you can see, it works. Now let me submit it to check if it can pass for all testing cases. Yeah, as you can see, it passed for all testing cases, and the time complexity is ON because this is a sliding window solution. Thank you for watching. See you next time.